Oh my God, this is unreal. He put me, Bill, David, Murphy. It's just something going on. Murphy, dude. This is the funniest kid.
Okay, so like I said, we have a nice easy lesson today for a change. We're going to do the trapezoid rule. It's real simple. If we were doing rectangles here, I would draw these vertical segments, and then I would decide which of the four rectangles am I using. Am I doing a left rectangle? Am I doing a right-hand rectangle? Am I doing an upper limit? Or am I doing I'm doing a lower limit? So let's say, for instance, I was doing a right-hand rectangle. I would look at this first one, go up the right-hand side, come across, go up the right-hand side, come across, and I would have something like that. You with me? This is all review. But you see that I have all this wasted space, which we've talked about in the past. How do I eliminate the wasted space? So I'll ask again, how do I eliminate the wasted space as much as possible?
Smaller rectangles.
Smaller rectangles or more of them, correct. And that transitioned into the definite integral and all that other fun stuff. We're going back to some approximations here. And we're going to use one simple trick. Instead of using a rectangle, we're going to change the geometric shape into a trapezoid. So I'm going to connect that point to that point and make trapezoids out of this.
Wait, what are you going to
Which gives me a much, much smaller wasted area in there. And so therefore should give me a more accurate answer. In fact, this first one isn't even a trapezoid, it's actually a triangle. So we'll pretend that that one doesn't exist. Okay, no. Right. The point where it hits the graph and the other point where it hits the graph. Yep. So this actually, I think I have black on it. Let's trace one of these so we can see the trapezoid. So it comes here, comes across here, comes up here, and down there. So it's actually a traditional trapezoid on its side. How tall is that trapezoid? Beautiful, delta x, because this is the height. So that's delta x, which in this picture would be here, delta x, which you know from geometry is the height. Oh, by the way, before we continue, do you remember the formula for the area of a trapezoid?
1/2 height base 1 plus base 2.
Area equals
1/2 times height base 1 parentheses base 1 plus base 2.
Okay, good. So we'll call this B1, we'll call this B2. Going from this trapezoid to that trapezoid, how big is B1? Oh, here, let's do this. One, we'll keep it simple. 1, 2, 3, 4.
Are we doing the first?
Are you stretching or raising your hand? Just doing some yoga, loosening up in case things get ugly. Excellent. Jimmy.
Which one is this? Is it the first one on the left?
Oh no, which trapezoid are we talking about? This
Yeah.
guy right here.
Oh, okay. So B1 is 2 and B2 is 3.
Not,
No, that's wrong.
not quite.
Alpha.
F of 2 and F of 2.
Beautiful. F of 2 and F of 3. These are vertical segments, so therefore it's the y value, so we have to take F of 2 and F of 3. Okay. Any problems there? Plug and chug, done. Okay. Now let's move on to the next trapezoid. Let's do this one. What's the area of that one? Okay, hold on. Let me finish this one. This was what's delta x here? 1. So we'd have 1/2 1 times f of 2 plus f of 3. Okay, so that's the first one. We'll call that area 1. So put a big capital in there. And we'll call this one 2. area of region 2. Still has a delta x of 1. What's B1? F of 3. And what's B2? F of 4. So I'm going to show you two ways to do this. One way is just to simply figure out the area of all the trapezoids and add them up. The other way is the actual trapezoid rule, which is a little bit more complicated and to me is a little confusing. But what you realize is that, if you didn't already, is notice there's a repetition between, in this case, f of 3. Because f of 3 is this shared segment between the two trapezoids. So if I just use the trapezoid rule, what I would end up doing is I would double all the shared sides and not double the first and the last. Okay, does that make sense? That confuses people all the time. They end up doubling everything, or they don't double anything, or they double the ends and not the middle. So I don't personally like to use that, but you can if you'd like. Okay, and it would look something like this. The actual trapezoid rule is area using a trapezoid is equal to 1/2 b minus a over n times f of n plus 2 times f of n plus 1 plus dot 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 plus 2 times f of however you want to do that, n plus some value, question mark, plus f of our last one, which we'll just call f of the end, which you clearly can't read. Okay. And to me, that doesn't make any sense. I prefer doing the geometric approach. If I've got 4 trapezoids, I just find the area of 4 trapezoids. If I have 3, I do 3. I don't have to remember, do I double the first one and all that other garbage. Draw a careful, just like we did with rectangles, draw a careful picture, break them into each thing. Notice this angle over here doesn't matter because it's not a distance that we care about. We care about the height of the two trapezoids and the width, which is delta x. Are you asking what that says?
Yeah.
F of n plus question mark, because we don't know how high we're going to go. And then f of the end, or the last one. It's not a real technical term, but you understand what I mean, hopefully. Okay? So let's do an example, shall we? Okay. Let's see, what are we going to do? Let's do, we'll make f of x equal to 3x plus 2. And we'll take a range from 1 to 5, and we'll make it easy. We'll make n equal to 4. Break it into 4 trapezoids. Just so you know, and so I don't forget, there's another method in this section called Simpsons Rule. We don't do Simpsons Rule. It's not an A-B topic. So if it says using Simpsons Rule also, skip it. What's that look like? Yeah. What's delta x?
1.
Why?
5 minus 1 over 4.
Good. Delta x is equal to 5 minus 1 over 4 trapezoids, which would give us uno. Again, keeping it easy. So, completely missed. Oops. Now here's the weird thing about doing this problem using a trapezoid rule is we're going to get the exact answer, because notice that the line, there's no wasted space here. But that's neither here nor there. 2, 3, and 4. Okay, area of trapezoid number 1 is 1/2 times 1. So that's 1/2 times the height of that trapezoid, which is delta x, which is 1, times 1, 2, 3, 4, 5. And I'm going to write it out the long way just so you can see what's going on. F of 1 plus f of 2. Are we good with that so far? How do I get f of 1? Plug it in. So I'll get 1/2 times f of 1 is 5 plus f of 2, which is 8. 13 halves. Okay, so far? 10,000 steps. Just got it.
No way.
I can't walk for the
What
rest
do you
of
mean, no way?
It's 11:12.
I ran this morning.
You always run. Now you can't walk for the rest of the day. You have to keep it fast.
Okay, I'll
just,
keep.
Just leave it on. Just leave it on here.
Where do? Huh?
It's gonna
Take
move
it off
if you
and
lift
stay
your
right
arm.
here.
Why?
Just keep it that fast.
No. 1/2 1 times. Okay, second one. What's the base 1? Let's do f of first.
F of 1.
No.
Wait, what? Oh, sorry. F2.
F of 2 plus f of 3, which is 1/2 times f of 2 we already did. That's 8 plus f of 3 now, which would be 11. And so we get 19 halves. All right, area of part 3, 1/2 1 times f of 3 plus f of 4. F of 3 I did up here, which is 11. Now I need f of 4, which would be 14. 25 halves. And so you start to see the repetition here, and hopefully, I think it's easier to visualize doing this than it is trying to plug into some formula. 1/2 1 times f of 4 plus f of 5. 1/2 times 14 plus f of 5 is 17. 31 halves. I lose anybody along the way? Are we good? Okay, so the total area and the answer to the problem would be 13 and 19 is 32, 57, 88 halves, which would be 44. Okay. Somebody take out your, or all of you take out your calculator. It'd be good practice.
Sorry. Thank you.
I want to check to see if that answer is correct. And one of the things I said here is that the trapezoid rule should give me the exact answer. The question is, what integral would I set up to find that area? I'll get you started.
It's 5 approaches 1.
Okay, from 1 to 5 of 3x plus 2 dx. Okay, do that on FNA and see what you get.
It's 44.
44. Hot diggity. We're happy. Okay. Again, if you want to use the trapezoid rule, you can. I just find it confusing. This, to me, makes a lot more sense. And even if you have more trapezoids, the process starts to become fairly repetitive, and you see that I started with f of 1, f of 2, then f of 2 to f of 3, f of 3 to f of 4. And I talked about that doubling you start to see here. There's 2 f of 2s, there's 2 f of 3s, there's 2 f of 4s, but only 1 f of 5 and only 1 f of 1. Question?
Why do we even do the rectangles first if this is going to be more accurate?
This here?
Like the trapezoid rule. Why do we even do the rectangles if we do this now?
For this stuff. It's a really good question. I can explain it to you, but you wouldn't understand. I honestly have never thought of it. I don't know why we do. Why wouldn't we just go right to trapezoid? Yeah, Connor.
For our example, the very first graph that you drew, you said that there was going to be a triangle on the all the way to the left. Would you like say?
Whoops, wrong way. Hold on.
Go
Nope.
that way.
Nope.
There we go.
That guy?
Yeah, when it makes a triangle and the one on the left instead of a trapezoid, would you just find, if you're going from 0 to 4, you have to add in.
Ready to have your mind blown?
Add in there.
What's B1?
It's 0.
It's a trapezoid with one base having a length of 0, which becomes a triangle.
Oh my god.
Trippy, right? Yeah. Yeah. I probably wouldn't use the trapezoid rule or formula for it. I would just do the area of a triangle, but
And then add it to the.
and then you add it to the whole sheet. Right? If we were going from 0 to 4, it'd be a different story. Okay, we good? Awesome. Delete.
Oh, thank you.